Lesson 4-10, we're going to be looking at scale drawings and models. So a lot of times you work with this when you're looking at maps. If you want to find out the real distance, obviously, you look at the map scale. And so maybe 1 inch on a map is equal to 5 miles or 10 miles or 2 miles or something like that in real life. So in order to find out how far it is or how far you still need to go or travel, you'll need to understand how scales work. Also, if you were to purchase like a replica of an airplane, like a model airplane, you know, a lot of times the model airplanes are identical to the real thing, but they shrink it down using a scale factor, and so everything is to scale. You know, sometimes you see on packages or boxes, you can say it's drawn to scale, or sometimes you'll see this is the real actual size of it. So knowing scale drawings and understanding scales can help you understand reference points and how maybe big or small things are. For us as students to be able to study the atoms of a human body or things like that, you would actually need to make those things larger. So you could have a model that's bigger than the real thing, or in the case of like a skyscraper, you would obviously want to shrink that down if you wanted to purchase a model of that and bring it home with you. So first, dealing with map scales, use the map to find the actual distance from Bingston to Allenton. So we're starting here at Bingston and we're going to Allenton. It is about 1.5 inches on the map, and so we're going to use this scale here and make a proportion. So we can say 1 inch is to 5 miles. Pretty much what I always do is you take your scale and you write it as a ratio. Don't worry about mixing any of these things up. Just take your scale and write it as a ratio right away. So 1 inch to 5 miles. And then this is 1.5 inches. Well, that matches inches. So we're going to write 1.5 inches on the top. And we want to know how far is it in real life. So we just make a proportion. And here we can cross multiply and divide. But here you can see that to get from 1 to 1.5, you just multiply by 1.5. So to get from 5 to x, all we got to do is multiply by 1.5 and we'll get there. So 1 times 5 is 5, and then 5 times 0.5, half of 5 is 2.5. So 5 miles plus 2.5 miles would equal 7.5 miles in real life. So we know then that if this is 1.5 inches here, we're going to have the full inch, which is 5 miles, plus another 1/2 inch, which is 2.5, so 7.5 miles. So again, this is the work I'm expecting to see. You can either show this, so you're multiplying by 1.5 to both sides, or you can cross multiply. And in this case, it's not too bad at all, because you see it's just 1 times x, and that's x. And then all you're doing is 5 times 1.5. So you're doing the same thing, and you're just maybe showing your work just a slightly different way. Either way, though, 7.5 miles is your answer. You can show your work one of two ways. For example 2, we want to find the distance between Springfield and Capital City. And my map scale is right here. Remember, what I do right away is write your scale as ratio, so 1 inch over 7 miles. And that's equal to, okay, the distance on the map is about 1.4 inches. So I put that on top because that matches my inches, and I'm looking for actual distance. So here, if we cross multiply, I get x, and I'm going to do 7 times 1.4. So since this is a 0.4, we'll go ahead and grab our calculators. So 7 times 1.4, and that equals 9.8 miles. And you don't even have to divide by anything, because our scale started with a 1, and oftentimes that is how scales work. You'll have 1 inch, 1 centimeter, whatever it is, it's going to be 1 unit. So you'll be able to see across pretty easily that when you multiply, you're just going to have x anyway, so you're just multiplying cross products to get your answer. So for example 3, a scale drawing, a wall in a room is 15 feet long. On a scale drawing, it is shown as 6 inches. So what is the scale of the drawing? Well, look back here. we saw that the scale is 1 inch equals something. And here is 1 inch equals something. So for scales, we don't want like 3 inches equals X amount of miles. I want to know what 1 inch equals. So that way, a lot of times it's pretty easy to figure out like a ½ inch of 5 is, 2.5. So I want to work with just 1 unit. So think of it kind of like our unit rates. So right now we have 6 inches equals 15 feet. I want to get that down to 1 inch, and I want to know how many feet is just 1 inch, because this is going to be my scale right here. I want it to be 1 inch equals this many feet in my drawing. So here again, all we need to do is cross multiply. So I get 6x equals 15, and divide by 6. So x is going to equal, and I'm going to have 2, and I'm going to have a decimal here, so 15 divided by 6 equals 2.5. So this actually works pretty well to find the distance. So 1 inch equals 2.5 feet, and that's going to be our scale of this drawing. Again, we want to get that down to be like a unit, 1 unit. 1 inch equals something. 1 centimeter equals something. 1 millimeter equals something. That's how our scales are shown. So when it asks what is the scale of the drawing, we want it down to 1. So again, we can always use our proportions to set that up. So we were actually working backwards. We saw all the measurements, but we needed to figure out what the scale was. So the length of a garage is 24 feet. On a scale drawing, the length of the garage is 10 inches. So we have 10 inches on the scale drawing, and we have 24 feet in real life. So we want to figure out what is the scale. So we want to find out just what is 1 inch, and what is that going to be equal to in real life. So again, cross multiply. So we get 10x equals 24. Divide both sides by 10. So I'm going to get x equals 2.4 feet. So 1 inch equals 2.4 feet. That's going to be our scale of the blueprint drawing of this garage. So when you're looking at the drawing of the garage, every inch is like 2.4 feet. So that's kind of how that works out. Okay, so now in this problem here, we're actually going to be looking for the scale factor. So here, this is just talking about the scale. So notice the difference between the directions. We're looking for the scale, 1 inch to 2.4 feet. Now we're going to be looking for the scale factor. Remember, factor is something you use to multiply. So a drawing of a room has a scale of 1 inch equals 2.5 feet. Find the scale factor. Well, the biggest problem here is that we have different units, which is common when dealing with scales. But if I have, a map right here, and I have a map right here, I want to know what was the factor used to multiply to get from here all the way to here. I want to know what is being multiplied, and you can't do that with different units. So I got to get these actually into inches. So 1 inch actually equals, well, 2 feet is 24 inches plus 6 more inches. So we have 30 inches. So over here it'd be 1 inch, and over here it'd be 30 inches. So to get from 1 to 30, we're multiplying by 30. So the scale factor of this problem is 30. We're multiplying from the scale drawing, we're multiplying by 30 to get to the actual distance. So you think of, here's the scale, 1 inch equals 2.5 feet, but the actual scale factor is every single measurement. 1 inch, you're basically multiplying it by 30 to get to the real dimensions. So your drawing is like a 1 to 30 replica. So you'd have to have 30 of these to equal the same size as this one. A drawing of a garage has a scale of 1 inch equals 2 2/5 of a foot, or 2 2/5 feet. Find the scale factor of the drawing. So again, we're looking for scale factor. We have inches and we have feet. So we need to figure out what is 2 2/5 of a foot. So, well, 2 feet, I know that's 24 inches. And so I need to find out what is 2/5 of 12, 2/5 of 12. So when I cross multiply and divide, I'm going to get 5x equals 24. We divide both sides by 5. So x equals, it's going to be just less than 5. So 24 divided by 5 is 4.8. So 24 inches plus an extra 4.8 inches, which, that makes sense because 6 inches would be half a foot and 2 is just less than half of 5. So 2.5 would be half of 5, and then I would have 6 inches. So we're looking at a total then of 28.8 inches. Now, it is important to notice that in our original problem, we were given a fraction. So we need to get 8/10 into a fraction, so 28 and 8/10. And then we can simplify that to be 28 and 4/5 of an inch. So we have 1 inch equals 28 and 4/5. So our scale factor for this problem, scale factor equals 28 and 4/5. So to get from our drawing to our actual size, you need to multiply by 28 and 4/5, which comes out to 2 2/5 of a foot. That'll be the same thing. To make a replica or to go to the actual real size, you're going to use that factor of 28 and 4/5. For our last example, we're going to talk about the Statue of Liberty. Augusta Bartholdi created several smaller models of the Statue of Liberty before creating the 152-foot statue that stands in New York Harbor. One such model was only 21 inches tall. So right now we're starting to see, okay, here's the Statue of Liberty, and it's 152 feet tall. And here is the model that's only 21 inches tall. So it says, what is the scale of this model to the final version? So it just says scale. It does not say scale factor. So we want to find not 21 inches, but we want to find 1 inch. So right now it's 21 inches over 152 feet. And we want to know what is 1 inch going to be equal to in the same situation. So we need to go ahead and cross multiply. So we're going to get 21x equals 152. Divide both by 21. So we're going to get x equal to, we need to take 152 divided by 21. And we're going to get about 7.2 feet. So about 7.2 feet. So 1 inch equals about 7.2 feet in this problem. So here it says use the scale to determine the length of the statue's index finger on the model, which is 8 feet long on the actual statue. So I'm just going to kind of do another drawing here. We have the finger is 8 feet on the actual, and I want to know how large it is on the original, or on the model of it. So we can either use this scale, which we know here it's an estimate, so or we can actually go back and use the real measurements also. So since this is already down to 1, I'm going to go ahead and use it. So I'm going to say 8 feet. So I'm looking for x inches over 8 feet. And I know that this is going to be 1 inch is 7.2 feet. So when you cross multiply, we're going to get 7.2x equals 8, and divide by 7.2 And so x equals, we need to take 8 divided by 7.2, so about 1.1 inches. And again, we need to keep in mind that we did estimate this 7.2, and now we did estimate 1.1 again. So this isn't going to be exact, but the finger on the index finger on the model of the Statue of Liberty is roughly about an inch long, just over an inch, be about 1.1 or maybe a little bit longer since we rounded. But that's how we would figure out the actual length of the index finger of the model using information from the actual Statue of Liberty. So if you have any other questions with models and scale drawings and scales and scale factors, be sure to check the examples on the online personal tutors located on Moodle.